For the next few minutes, I want you to think about just how much human history survived because someone, somewhere, figured out how to keep water out of a wall, off a beam, or away from a foundation. Moisture has always been the great uncredited destroyer. It rots timber silently. It dissolves lime mortars, grain by grain. It creeps through stone joints and carries frost with it. Entire buildings that stood strong against invaders or storms ultimately collapsed because someone underestimated dampness. Yet, long before modern membranes, vents and concrete additives, builders developed moisture barrier systems so effective that some structures have remained dry for centuries. And the forgotten genius of those methods isn't just interesting trivia. These techniques offer practical, low-tech solutions that anyone working with off-grid shelters, homestead structures, or restoration projects can still apply today. That's why, in this episode of Thermal Vault, we're going deep into historic moisture barriers. How they worked, why they lasted, and, well, how their principles can still protect the structures we build now. To understand historic moisture barriers, we first have to look at the fundamental problem they were designed to defeat. Unlike modern construction, historic builders didn't have plastic sheets, bituminous rolls, or synthetic flashing. The primary enemy was ground moisture migrating upward, lateral moisture penetrating from rainfall, and, humidity condensing inside poorly ventilated spaces. Historic barriers weren't just single materials, but carefully designed systems that combined drainage, breathability, and capillary control. This is the key theme across all traditions, whether you study Roman basements, Japanese macchia, or, say, medieval European stone houses. Rather than sealing structures airtight, historic builders created layered barriers that slowed water, redirected it, and allowed trapped moisture to escape. This balance, stop water movement while allowing vapour movement, is precisely what makes so many ancient methods still relevant today. One of the most effective historic barriers was the Roman use of raised plinth foundations with capillary breaking layers. Roman builders understood that moisture climbs upward through stone and brick, so they inserted a deliberate break between the soil and the occupied floor. This could be a layer of crushed pottery, volcanic sand, or tightly compacted gravel that refused to wick water upward. You can actually apply this same method today when building, say, an off-grid shed or a small stone structure. Before laying a single stone, you'll want to excavate several inches below the floor level, spread a compacted layer of gravel, at least the depth of your fist. And, make sure there are no fine particles that could wick moisture. Another powerful historic method was found in medieval Europe, where builders developed these rather clever, breathable wall systems. Instead of trying to block every molecule of water, they worked with the reality that walls absorb moisture, but must also release it. Timber framing filled with wattle and daub, or full lime-plastered stone walls, served as natural moisture regulators. Lime plaster, in particular, was a genius barrier. It resisted liquid water, but its microscopic structure allowed vapour to escape before it condensed inside the wall. That's actually why, Medieval lime-plastered buildings can last for hundreds of years without any internal rot. If you're restoring an old structure, or even building a simple rural workshop, replacing cement-based plasters with lime-based ones allows your walls to breathe, really. The practical step is, honestly, quite straightforward. Apply multiple thin coats of lime plaster, allowing each to set, rather than just one thick cement coat that traps moisture inside. In humid regions, this difference can, save your timbers from decades of hidden decay. Japan provides another masterclass in moisture control with its raised floor architecture. Traditional Japanese homes were, engineered to float above ground humidity. Builders created elevated floors supported by stone piers, leaving a ventilated crawl space underneath. The airflow prevented condensation, dried out occasional water intrusion, and stopped microorganisms from colonizing the timber. So this approach actually translates perfectly into, modern off-grid cabins and lightweight shelters. If your climate, say, experiences frequent humidity swings, you can just build your structure on piers or posts instead of a solid slab. Leave at least a knee's height of space under the floor and make sure there's cross-ventilation through openings on opposite sides. This airflow, really, it performs the work of modern vapour barriers without any manufactured materials. Historic moisture barriers also relied on intelligent drainage design. Many ancient structures stayed dry, not because their walls were waterproof, but because water never had the opportunity to accumulate around them. The Incas, for example, created subtle stone channels and graded terraces that directed rainwater away before it could seep into foundations. Even Viking longhouses used exterior perimeter swales to divert runoff. So, to apply this today, stand where you plan to build after a heavy rain and really study how the water behaves. It's quite fascinating, actually. Then carve shallow drainage ditches that lead water downhill and away from your structure's footprint. Simple, yet effective. Now, let's combine this with a gravel apron around the foundation. This is to prevent rain splash from saturating those lower walls. You see, it's often the unsung hero in construction. These small earthworks often matter more than the moisture barrier itself. It's the little things that can make a big difference, wouldn't you agree? Now, another overlooked technique is the membrane in layers principle, which was, used across the Middle East and North Africa. Builders in those regions used alternating layers of clay, lime and stone to create a barrier that would swell when wet and then, crack open when dry. This dynamic movement actually prevented water from penetrating deeply, while still allowing for evaporation. So, if you're building an earthen structure, or even repairing one, you can adapt this method by using alternating layers of coarse soil and lime-stabilized soil. So, the key is allowing the clay layer to form the water seal, while the lime layer acts as a release surface. What all these traditions teach is that moisture control is fundamentally a balance, not a battle. You know, historic builders understood things like capillary action, airflow, drainage, and how materials behave, all quite intuitively. Their methods have endured because, well, they solve the problem right at its source, keeping water moving in the direction you want and blocking it where you must. If you found this deep dive valuable and you want more historic engineering breakdowns brought into practical modern use, make sure you subscribe to Thermal Vault and share this guide with your fellow enthusiasts. And, you know, keep exploring the knowledge that has kept humanity's structures standing for thousands of years.